Force multipliers and speed multipliers and mechanical advantage, oh my! Let's learn physics. Let's imagine that you have a simple machine. Could be any simple machine. Could be something like a lever, first class, second class, third class. Could be a wheel and axle, or could be something like a pulley system. Doesn't matter what it is, but you have a bunch of machines. Now what you're going to do is you're going to apply a force of exactly 200 newtons to every one of these machines. And you're going to apply that force over a distance, a displacement of 2 meters. And you're going to apply that force at a speed of 3 meters per second. This is all your input. Your input is 200 newtons, 2 meters of displacement, 3 meters per second of speed. All of these machines have a different mechanical advantage. The mechanical advantage of the first one is 2, and then 4, and then 7. So you're increasing the mechanical advantage. Then you're going to a mechanical advantage of 1, and then you're going into the fractions. Now mechanical advantage can't ever be less than 0. So it's the 0 to 1, the 1, and the greater than 1. So less than 1, 1, greater than 1, but not negative numbers. These are all decimals that are less than 1, greater than 0. And your job is to figure out how much output force would there be. Now we're assuming that there isn't any friction for this discussion. How much output force will there be from the machine? This is the force that the machine applies at the other end. This is the force that you apply at this end. And how much output displacement or distance would there be? And how much output speed would there be? Now some of these are force multipliers. Some of them are distance multipliers and speed multipliers. So let's do this. All right, 200 Newton force, mechanical advantage of 2. Well, and this is where everybody thinks all the machines go. 200 times 2 gives you a total output force of 400 newtons. You're like, oh, look at that, it doubled my force. It's a pretty good machine. 200 newtons times 4 gives you 800 newtons. And of course, 200 newtons multiplied by 7, you get the picture, right? You're getting this pattern. 1,400 total newtons of output. You know, oh, that is a really good machine. Now there's always a trade-off, and this is where the conservation of energy comes in. The trade-off is that you get more force, but at the expense of distance and speed. Work is force times displacement. Work in input is equal to the work output. In this situation, everything's perfect. So you're going to get more output force, but less output displacement. And you're going to multiply the force, but you're going to divide, using the exact same number, the distance. So you start with 2 meters. Mechanical advantage of 2, you multiply to get the force, and you're going to divide to get the new distance. So 2 meters in, 1 meter out. 2 meters in, multiplier is 4 for the force, but then that's going to divide the distance, right? So 2 over 4 is 1/2. That's a half a meter, or 0.5 meters. And then 7, it's going to really multiply the force, but it's going to really divide the distance. 2/7 of a meter. 2/7 of a meter, which is 0.28 meters. It's 28 centimeters. So you start out here with a 2 meter input displacement, which is like this, the height of me and my wingspan. It's about 2 meters, and you end up with, in this case, 28 centimeters. It's about that distance. But you get a huge amount of force out, but that output force times that 2/7. So you see that pattern? This, 200 times 2 gives you 400. 400 times 1. Oh, work input, work output, right? 200 times 2 is 400. 800 times a half is 400. Oh, okay. So I've got this constant work. 200 times 2 gives me 400 joules of input work. 1400, 2800 divided by, oh, that 400 joules, again, of output work. So work, energy conserved, and you're just going to get a bigger force with a smaller displacement. So energy is conserved. You don't get more work out of the machine. You just get more force, but less displacement. Those are what we call force multipliers. Therefore, because they're force multipliers, they also divide speed and distance. Oh, we haven't gotten to the speed yet. Let's do that. 3 meters per second. Half of that speed, this is 1.5 meters per second. 3 meters per second input speed divided by 4 is 3/4, or 0.75. 3/4 of a meter per second. And then finally 3 meters, 3/7 of a meter per second. So it's pretty small. These top 3 are force multipliers and speed and distance dividers. You can tell by looking at those numbers. Now, if you have a mechanical advantage that is 1, exactly 1, that is just a direction changer. And that 200 times 1 gives you 200. 200 newtons of output force. You don't think that's a great machine unless, rather than lifting up, you can just push down and use your weight. Great advantage to these kind of things. Single pulley looped over at the ceiling. You pull down rather than pulling up. It's a whole lot more convenient, easier to do. And 2 meters, well, it's divided by 1, 2 meters, and 3 meters per second. Doesn't look like it's useful unless you have to extend the force somewhere or use your weight pulling down rather than pulling up. Middle one's a direction changer. Now, down here at the bottom, these are weird because the mechanical advantage is a fraction less than 1. So what's the point? Because if I have a fraction less than 1, and if all these numbers, we took the input force and multiplied to get a bigger output force, 200 times a half, this is 100 newtons. Wait a minute, I'm getting a smaller output force. That doesn't make any sense. And 200, quarter of 200, that's 50 newtons. 50 newtons output. And a seventh of 200, because it's a seventh of 2, we're getting 200 sevenths, which is like 0.28, 28 newtons. So really small. I'm inputting 200 newtons of force to get out 28 newtons. That doesn't make any sense unless you pay attention to the output distance or the output speed, and 2 divided by 2, or just multiply, because you know that this is not a force multiplier, it's a force divider. It's a speed and distance multiplier. So 2 meters times 2 gives you 4 meters. Oh, that's the point of this machine. 200 times 4 gives you, or 2 meters times 4 gives you 8 meters. And 2 meters times 7 gives you 14 meters. You get a whole lot of distance, and that's what you want in these particular cases. You want speed and distance. Speaking of speed, 3 meters per second times 2 gives you 6 meters per second. And 3 meters times 4 gives you 3 times 4 is 12. Wow, you're getting some pretty good speed out of this. You're putting 3 meters per second in, you're getting 12 meters per second out. It's pretty good for that reason. 3 times 7 is 21. 21 meters per second. So you get a whole lot of good speed out of that. So these are speed and distance multipliers. But unfortunately, they have to also be force dividers. And you can do the same thing. 200 times 2, that is the 400 joules. 100 times 4, 400 joules. 200 times 2, 400 joules. 50 times 8, 400 joules. Same input work as output work, but you're just getting a whole lot of speed. Trade-off is that you have to apply a big force to get a tiny force over there. Now, keeping in mind our conclusion that these top ones with a mechanical advantage greater than 1, they're force multipliers and unfortunately distance and speed dividers, and that the mechanical advantage of 1, they just change direction. And then these bottom ones with the weird mechanical advantages and the strange, complete, horrible loss of force, the goal of those things is to get more distance and speed out. Let's go to some practical machines. Now this is a basic lever, and you can tell, oh, well, my input, because wherever I apply the force is the input, my input is a large distance, and I get a small distance out. That, just by looking at it, is a speed and distance divider. Therefore, it's got to be a force multiplier, and it's pretty easy. Oh, that's pretty easy. Now, if I switch it, check this out. If I switch the input and output, this becomes really, really difficult. Requires a significant amount of force to lift this thing. It's a whole lot harder, but notice, look at how much this thing moves. Output moves a whole lot more, and that position is moving a whole lot faster. It's like my arms and my legs. Those things are speed and distance multipliers, and well, mechanical advantage of less than 1. And this one, mechanical advantage greater than 1. This is a pulley system. This little pulley system right now, you can just count the number of supporting strands. 1, 2, 3. This has a mechanical advantage of 3. It's a force multiplier. You can tell by looking at it because as you operate the machine, I start applying the input force here. My hand starts here, goes all the way to the ground, and this thing starts there and just moves up a little bit. So the input distance moves a whole lot more, and the output distance is a whole lot less. And so looks like that's a speed and distance divider, so force multiplier, and that's a 3. Check this out. You can also change the positions of the input and the output and make that force multiplier into a speed and distance divider. Now watch this. I'm going to pull on this one. That becomes my input. And now, whoo, look at how much that thing moves, right? So this is now a mechanical advantage less than 1. In fact, since the other one was a 3, this is now a 1/3 mechanical advantage, which multiplies speed and distance by 3 and divides the force. This is now a whole lot more difficult. I would have to apply a lot of force. In fact, this is lifting about 10 newtons. Well, I have to apply about 30 newtons of force. And this 20 newton scale, can't even measure it. It just maxes out and I can't even measure it. This is a wheel and axle. Wheel and axle, you have this solid thing and you're applying a force at one radius and the output force is at a different radius. And, well, in this case, I pull, and that actually is a pretty significant amount of force that I have to apply. It requires a whole bunch of force to get that thing moving, but you'll notice, this looks like a speed and distance multiplier, right? Because the output is moving a whole lot more than the input, my hand. So I immediately conclude by observing it that this is a speed and distance multiplier. The mechanical advantage is less than 1. But if I switch them, take the input and the output and switch those two and apply my force here. Oh, that is so easy. Input force is really small, but I have to apply that input force over a large distance. Looks like the top portion of this, and this is a force multiplier, and actually the ratio of radii, diameter, circumference is about 3. So my mechanical advantage is 3, but it was 1/3 when connected like this. And I get a whole lot of distance out of it. So, basically, just keep in mind this little chart right here. Remember, mechanical advantage that is 5, greater than 1, it's a force multiplier. So you take your input force, make the output force bigger. You take the input distance and speed, and this is the trade-off, make the output force and speed smaller. That's the mechanical advantage greater than 1. If it is exactly 1, like this could be, if we made the two arms exactly the same, make those two arms exactly the same, that means that you push down 10 centimeters, that goes up 10 centimeters. You push down with 10 newtons, that goes up 10 newtons. But it's nice because you can just sit on this thing and really not apply a whole lot of effort. That's a mechanical advantage of 1. And the exact same size of force, the exact same size of distance. But down at the bottom, these things are speed and distance multipliers. That's the point. That is a good thing. You want to multiply speed and distance, but unfortunately get a lot smaller force out. And remember not to confuse efficiency. If I give you a 1/7 efficiency, a machine that is 1/7 efficient, or 0.14 efficient, like 15% efficiency, well, that is not a good machine. A 0.15 mechanical advantage, that's a good speed distance multiplier. But a 0.15 efficiency loses 85% of the energy. Keep that distinction in mind. That'll make sense, right? Now I've got to do some numbers with actual versus ideal mechanical advantage. Maybe I'll do that next. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.